Okay, this is lesson 59. Not going to really do much with this, this first section. We've got this experimental data here, and what happens is in an imperfect world, you start making some graphs here, and you start graphing points. And notice these points don't follow in a straight line. But what you end up doing is you do what is called a line of best fit. So you draw a line that is as close to possible. It's kind of like the average here, there. And that ends up being the line of those samples that you got and you end up putting on there. And that's pretty much all I'm going to have you do with that, is just understand that, you know, when you have all of these lines on here that aren't a straight line, you draw a line of best fit, and it's kind of like an educated guess that you're just kind of coming up with something that looks like it's pretty close. And so just be familiar with that phrase, line of best fit, the line that fits the best. Alright, so we're going to look at 59B and 59C, and then we'll be done, and there's not a whole lot there. Okay, this is, let's see, what example is this? Example 59.3, bottom of page 253. Alright, sometimes you have a system of equations, and remember a system of equations is just two equations here. That's all it is. We've got an A and a B, two equations. But it looks pretty confusing because I have fractions up here and decimals down here. So what we're going to do is we're going to get rid of the fractions and get rid of the decimals. Alright, so what I do is I put a parenthesis around the entire equation with a fraction, and I find the least common denominator, which is 10. 2 and 5 both go into 10. So then I multiply 10 times each part of it. Can you hear the music from my wife watching her TV show in the other room? Alright, now we cancel. And that, all that did was got rid of, okay, multiplied those, all that did was got rid of my fractions. So this is the exact same thing as that, we just got rid of the fractions. Alright, so let's look at my decimals here. So let's get rid of the work we did up here to get the first one. Alright, now the decimals, what I do is I look for the smallest number, or the number, let's see, how do I say that? The most digits to the right of the decimal. Okay? So this one has 2, this one has 1, this one has 2. So the most digits to the right is 2. And that is in the 100ths place. So I multiply the entire thing by 100. And what that'll do is this times 0.06 gives me 6. 100 times 0.2 gives me 20. And 100 times 1.04 gives me 104. Okay, so that looks so much nicer. 6x minus 20y equals 104. Now, I've got my system of equations without my stinking fractions, and that's a good thing. Okay, so let's move everything up a little bit. And what I do then, if you remember from systems of equations, we're trying to, we're trying to add those. We're trying to get rid of the variables there. So the way we get rid of the variables is we can either make both of these the same number or both of these the same number. I'm thinking that both of those first ones are going to be the choice to go. So what we're going to do is we're going to find the smallest number that both 5 and 6 go into, and that would be 30. So I have to multiply the top by 6 to get that to be 30, and the bottom by 5 to get that to be 30. So the top number then, when I distribute that 6, is going to be 30x plus 36y equals negative 24. And when I distribute this 5, I'm going to get a 30x minus 100y equals 520. Okay, actually, I do these a little bit different than maybe you were taught. I look at this and I say, alright, so these are both the same numbers. How do I get them to be 0? Well, I get them to be 0 if I were to subtract 30 from 30 and get 0, right? So then 36 minus a negative 100 is the same as 36 plus 100. And 24 minus 520 would be, negative 24 minus would be a negative 544. Divide by 136, divide by 136, those go away. 544 divided by 136 is going to be negative 4. And that's my y. And then in order to find my x, I take my negative 4 and I plug it in here, and I solve for my x value. So I would have, let's do that in red, 5x plus 6 times negative 4 equals negative 4. So 5x minus 24 equals negative 4, and I just keep going from there, and I get 5x equals 20, x equals 4. So x equals 4 and y equals negative 4. And that's it for what we're doing there with systems of equations. Alright, so the last part of this section is rectangular form to polar form. And I'm going to have to look back and see if we've done this at all. Okay, it looks like back in lesson 54 we changed from polar to rectangular. In this lesson we're going to go from rectangular to polar. Okay, I knew we had done one or the other, but just didn't remember which one we did. Alright, so let's get started here. Alright, so this first example, we have negative 5r minus 3u. And we're trying to change that to polar form. So what I do is I first of all graph that. Negative 5, negative 3. There's negative 5 and then down 3. So there's my point. I'll draw that there. And I draw a triangle. So this is 5. And this is 3. And I go ahead and look at which trig function I'm going to use. I have a choice of tangent, sine, and cosine, right? Well, if this is my angle right here, this would be my opposite, this is my adjacent. So those are the two numbers I have. So the trig function that uses opposite over adjacent is tangent. So I'm going to use the tangent. So what I'm trying to do here when I do polar, remember, is I'm trying to find this angle and the length of the hypotenuse. So by using tangent, I'm finding the angle, and then I'll use, possibly I'll be using Pythagorean then to find out the hypotenuse later. So right now we're finding this angle. So we're going to use tangent, because tangent is opposite over adjacent. That's what you always use when you're converting from rectangular to polar. So tangent of some angle, we're going to call it theta. That's our variable, that's our unknown. And that's going to equal opposite over adjacent. So I don't have a calculator here, but 3 over 5 is approximately, no, it's exactly 0.6. Okay? That is not the angle though. So what I have to do is I have to take the tangent negative 1 of 0.6. Plug that in your calculator, and that will give you your angle here. And that angle then is a 31-degree angle. Alright, so when you change from rectangular to polar, remember you're going from rectangular to a number here at a degree inside of there, and that degree we just discovered is 31 degrees, so that goes there. Now what we're doing is looking for the number that goes there, which is the length of the hypotenuse. So we take one side squared plus the other side squared equals the hypotenuse squared. So this is 9 plus 25 equals the hypotenuse squared. So this is 34 34 equals h squared, and let's move this up. So 34 equals h squared, so we take the square root of both sides to get rid of the h squared, so h equals the square root of 34. You don't have to put the plus or minus here because the length of a hypotenuse can never be negative, so you know it's just going to be positive. Alright, so what we've got here is we've got the length of our hypotenuse at 31 degrees. And that's how you convert from polar form to, or rectangular form to polar form. And that's it for lesson 59.